Hi. So, oh, my fingers. I'll record another bit, but don't be too scared about all the questions I'm going to give you through Jack Plus. I'm expecting those to be done over time and kind of practiced. I'm going to zoom in a bit, might make it easier. Okay. Right. So, we're looking at pathways. I think that's easier to do now at home than our other stuff was. So we'll do some pathways. We'll look at chromatography tomorrow, come back to pathways, then look at titration. Hopefully this will work for us. Hopefully we'll back and we can do the chromatography and titration kind of and get a bit of hands-on. Otherwise I'm going to send you some videos. You know, this is what it is. We're figuring it all out. So this is an exam question. I think this is the easiest way to do it. So I've given you a document. I want you to fill in the gaps. And I'm sending you kind of a pathways, what's it called? Like a pathways flow chart. I'd suggest the first few times you do these kind of questions, you use it, get practicing with it, and then start kind of taking it away. So don't feel you have, I mean, this is my way of doing it. Don't feel you have to remember everything all at once. There's a lot in there. So maybe do a couple with it, then take it away, but don't feel that you can't look at it and then take it away completely because you're not going to have it. Right, so this is the question. I've had to take one bit out because it's been taken out the study design. It's starting to kill me because there's just so many little bits and I'm like, is that in? Is that not in? Oh, I can't remember. Let me double check. Yeah, it's not there. Blah, 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 blah. So give it some time. So you will have a question very much like this. You will have your pencil. As long as you are drawing heavy, there is no issues with using a pencil. You just have to make sure it's going to copy. You will have your data book. I'm not clever enough to have brought my data book, but luckily it is in the back of the textbook. Well, they said Rolo textbook. So, oh, and this is the, so you have been given this diagram showing you all of the pathways. So if I want to make a carboxylic acid, so the question might be, I'm making a carboxylic acid. There's lots of different ways I can get there. So I can go through, I can go an alkene and then I can get from here to an alcohol through that steam process. And then I can go from here to an aldehyde and then from an aldehyde to a carboxylic acid. Or I can go straight through, no, those two are combining, yeah. I can also go, can I go any other way? Yes, I can go alkene, alkane, bromoalkane, or I can even go this way to an alcohol, so the same as this but more steps, then across to here, where was I going? And then across to my carboxylic acid. So that's kind of what you're going to be thinking of and doing. You're going to have to remember these reagents. I don't know if I've seen many where you have to remember the temperatures or things. No, I don't think I have. Right, so you have to remember what you need to make it. So these conditions, any catalysts and things, but I don't think you've used any temperature. So the things to consider are how many steps. So if I have to do 10 steps to do anything, it's going to be much harder than if I have 2. And that's the thing you have to consider. You also have to consider conditions. So if it says to go from here to here is hugely high temperature, that's going to be quite expensive. Is that going to be more cost efficient than going this way? So these are the kind of things. So it's taking some of that further thinking about why we do this stuff and applying it. So this is all a bit, what's his name, Walter White, you know, when he was making his meth, he wanted to make his meth, which was somewhere, it's not in NH groups, amine groups, I think it's got off the top of my head. So he wants to be making this, he has his starting, he's got different steps he wants to go. He could go this way, he could go that way, he could go that way. It depends, you know, on costs and whatever. He wants to make his drugs as cheap as possible. Right, so the question. So it's good, I say good, it's going to ask you several things all in one go. Right, so we have our data book. Start looking at this again. Looking at what you have and what you don't have. So it's going to be really useful for these kind of questions because you have this. So I've got to draw a structural formula of 2-methyl propan-2-ol. So I then go, I can never remember these. Prop is how many? Oh, look. In my data book, it tells me I've got 3. So prop is giving me 3. So I know I've just got 3 carbons. So that's easy there. 3 carbons. That means I've got an OH. 2-methyl means I've got 1 carbon on the second carbon. Okay. Don't forget you've got to show all of the information here. So you can scribble as much, but you have to make it clear, and you have to show all of those hydrogens. You have to show all of the alcohols. You have to show all of your understanding in one little kind of sketch. So 3 carbons for my prop. So 1. Prop. 2-methyl. So this is the second one. There's no other way. Whatever way we count is a methyl. Two-ol. So my alcohol is also stuck on this second one. So I probably should have spread these out a bit. My writing's too big. Right, so I've included all of my hydrogens. I've included all of my bonds. They're kind of neatish. I've shown up my understanding. Another thing to check, structural formula. So don't get overexcited drawing something that you don't have to. And again, structural formula, they give you this information. They give you this information in the data book over here. So structural, I need to draw it. Molecular, I just have to say how many of each. Doesn't give me much information. That's kind of what we've been using up to now, like for our specs and things. Semi-structural is condensed. That gives us this, but squashed down to this information. Skeletal is just these lines. So make sure you're checking, you're comfortable with this, and if you're freaking out, remember it's there to help you so you know what you're doing in the exam. So molecular formula is just going to be like this one. So your molecular formula is just going to be telling me how many carbons, how many hydrogens, and how many oxygens I have. Well, not oxygens because it's not that one, but how much of the different atoms I have. So I personally would, no, I wouldn't, well, yeah, I would probably have to revise and struggle this. I go, well, how many? So bute means I have 4 carbons. 2-ene, so that means there's a triple bond somewhere in there. So it's on the second. So that one's going to be a CH3. That one's fine. That one's CH3. So now I know it's going to be C4H6. So it's fine to be scribbling down here. They're not going to be looking. Oh, I can't even see what I did. That's not very useful. So it's going to be fine to be scribbling down here because this is where they're going to be looking. This is where they're going to be looking for your answer. So there is that N, you know, CN -1 + 1, whatever it is. I can't remember. I never remember them. Anyway, it's easier for me to do it that way than to do it that way. That's just my personal preference. Give the naming of this. So give the name of this compound that has the structural formula. Right. So we've got this structure. You need to name it. So highlighter or coloured pencil or whatever, but highlighter is going to be the easiest. And if you have a few, you can do different things. Right. So longest chain. 1, 2, 3. 2, 3, 4, 5, 6. Again, I can never remember what 6 is. My job is to teach, not remember. Well, you know, I have to do both, but there are certain things that do not stick in my head. 6, it doesn't tell me. It must be 1, 2, 3, 4. Is it hex? Hex. Yeah, hex. It's hex. Oh my lord. Right. I was also a maths teacher, strangely. Right, so it's hex something. Hex something. Right, so we've got hex. No double bonds, so it's hexane. Right, this is our, I'm going to call it business end. I'm sure there's some fancy technical term. Active functional group end. Yeah, functional group end is probably better. So this is where we have stuff happening. There's nothing happened down in this end, so this is where we start our counting. So we go 1, 2, 3, 4, 5, 6. So that's counting. And we have on 2 and 3. We have dibromo. Because we have 2 bromines. So there's dibromo. Because there's 1 and 2. Try if you had another one down here somewhere, but we've only got the 2. So 2, 3 dibromo. Then the next bit we need to go to is, where did we have this one? This little chappy here is on 4 methyl. So we've got these little bits and we have to put it together. So we have 2, 3 dibromo. Right, only 30% of students got that one right. So if you can get, this is going to be that top level kind of tweaking. So these are going to be the kind of ones that the top students are going to get, and then other students aren't. It takes a bit of time, but again, this is what they're looking at. And you could even like put a box around it if you don't want them to look at it. So this scribble here is just for you, so you can scribble to your heart's delight as long as it's clear kind of what the answer is. That's kind of a bit of revisiony stuff. This is the newer stuff. Right, so we've got a reaction pathway to make our compound P, but our compound P is not something we're looking at anymore because we're not looking at that amine stuff. Some of the stuff here, that's gone, so we'll just do these 2 bits here. There are lots of really complicated examples. Just start small and easily to begin with, then, you know, and with the revision notes and things to begin with. So it's going to be a backwards. Don't just launch. I would never launch into these questions without looking at this bit, because it may look up here as if it needs you to do something, but there might be different instructions down here. So identify the starting substance compound M by writing its semi-structural formula in the box. So semi-structural is like this one. So this is our semi-structural. And we need to write what we started with in here. So we get given this information. So we've got propan-1-ol. So we've got our propan-1-ol here. So we know that, and we've added some water and some acid. So we've got some water and some acid here, and we've got something happening here. So we look at our book to begin with, but you're not going to in the exam, but you know that we've got this alcohol and we've added some water to something. So when we're adding water, we're going to be adding to our alkane. So I'd cross a double bond. So it's called hydrolysis. Hydrolysis, addition. No, I should know these names. So we've got this adding across a double bond. So we know there's a double bond in here somewhere. So must have a double bond, and we're getting propan-1-ol. So because we're getting this propan-1-ol, it means that the double bond must be, you know, towards the end, so it can kind of add across, if that makes sense. If we've got it here and the carbon's here, that kind of is cracking open and allowing stuff to stick onto this carbon that's sat on the end. That makes sense. Right. So we got propanol, so we're not adding any carbons, we're not doing anything there. So we must have a CH3. We must have our CH double bond, and then so this is the bond that's been broken. So then we can add our stuff in here. That's what my semi-structural. I would then go in to really show that you understand, and I'd make sure that it's clear that we don't have. I have seen semi-structural where they've included it. I would not. I'd just hedge my bets. Remember, again, they're looking in the boxes, so all this crap can be all around here. It's not going to harm you in any way, shape or form. Right. 60% got that one right. Again, it's going to be a bit of investigation. So we're going from our alcohol here, and we're going, what's this called? Oh my god, I should know this. Good grief. It's not ketone. Carboxylic acid. Oh my god. Carboxylic acid. Good grief. Right. So we're going to carboxylic acid here. And we need to know what we're going to put in. So if we look here, we need something that's acidified. And we need some ions in there. So this is the one where the commonest one is chromate ions, or potassium manganate. You need to give the formula. So you need to give the formula. I can't find it anywhere in the data book unless I'm being blind as bad. So you're going to give the formula. 2, 7 minus, or and you need to include this acidified bit. This bit we're not going to do because it's gone. This one, question 50% got it wrong, 50% got it right, because not doing this bit right. So I'm going to whack some of these study click questions up for you. Again, as I said, try them first kind of with a bit of hand holding, looking at the book backwards and forwards, then try a few on your own.